Let me.
All right,
Remember,
we're
there's
recording this lecture 7 of algebra, and I'm switching over to Karen. Hang in there just 1 second.
No problem.
Switching over, and now you're going to be a presenter.
Coming, yep, it should be coming soon.
All right, I'm muting myself out. Have a great session. Thank you, guys.
Thank you so much. So hopefully you guys are all doing great this morning. Can you all see my screen? Let me know through the questions box. I want to make sure you can all see my screen. It's a grid, a giant grid. Okay, cool. Good to know. All right, you guys. Good to see you all. I'm hoping you guys all got to see your midterm grades and stuff. It was hard, but we did it. We got it up there. There's still a few things to go back and kind of just polish up, but you know, I think you guys did pretty well. I mean, really, everyone did really well, you know, considering that was it was not as easy. I felt for you guys, I really did, and I'm proud of every one of you, not just the people who are here in the live portion of the webcast. Everyone who's watching this later on, I'm proud of you all. You guys work hard in this class, and I don't want you to think it goes unnoticed, okay? So, you know, of course, if there's anything you guys need to ask me about, get in touch with me. My information, my contact information is on the syllabus. It's in the top of the main page for the class. In the syllabus, you can find my information. You can find it posted in the general forum a few times. You can text me. It's okay to text me. It's not a problem, okay? You, of course, email me if you feel better with that. That's fine. You can even call. I don't mind that, especially on Tuesdays and Thursdays, you guys. I generally check everything all day. And I want to say this, too. If you guys need to sit with me in a virtual office and get one-on-one help, I'm here, and I'm dying for the chance to do that. I actually got to do that a couple of sessions of live virtual office with just one-on-one. Someone needed some help with some stuff that they were having trouble with, and we were able to do that. And so I think I have another one today, and I can fit up to 3 people in there. Those are just, they're not recorded. It's just for you guys to get individualized help. So anyway, I'll be here around this afternoon if someone would like to inquire about that. Okay. At any rate, let's go ahead and just look at some problems. How are you guys with the homework that you're about to turn in? This is going to be, let's see, let me open up my homework that I had sent my file. Here it is. Okay. Okay, so we are about to turn in 7 tonight, correct? Is that right? Is that what I'm saying? What I'm remembering? Yeah. Okay. So, is there any topic in there that's giving you guys grief right now? You know, I know we didn't really look at that. We looked at 6 last time. So I'm going to look at some things in 7 just to kind of get you guys okay with that. I'm just kind of forwarding to 7 right now on my little printout, just to kind of see the stuff you're having to deal with. Okay, we did look at slope-intercept form. We can go through that. I think, was it Michelle, you had a question through a text or an email? Either you or maybe it was Viv. Okay, number 14, there are 2 questions or 1. Okay, number 14 on 7. Is this find the equations of line through 2, -9, that's perpendicular to a line with slope -3. That's it? Correct? That's good, because that's kind of one of the topics we would be going into next. Let's talk about that, okay? Just to kind of remind you, and I'm minimizing my questions box. That kind of helps out. I think you're going to like what I'm about to look at. Okay. Let me get my little graphics pad kicking. Oh. Hold on, guys. It's not plugged in. That's not going to work. Okay, so what we need to think about, okay, we looked at what the standard form, right? Let's kind of just write this across the top, okay, of linear equations, the standard form, just to kind of have them up here. And let's see, let me minimize this too. There we go. And let me get that kicking too. Okay. One thing quickly I want to do is I want to make the small grid. Yeah. So that way when I go to graph, it'll be more visible. All right. So let me see. Oh no, go back. We want standard form was the AX plus BX plus equal to C. Okay. So let's see. Let's write it on top just to save time. Standard form of the equation, linear equation, AX plus BX equal to C. And A, B, and C were integers, right? A, B, C are all elements of the integers, okay? Integers, okay? And then we said we looked at slope-intercept form, where the slope and the y-intercept were readily available as soon as you saw it in that form. So slope-intercept form was this. Y, you just solve it for y. Get y by itself is equal to mx, right? That's the coefficient on x is your slope, plus b. And then the b, right? When we let x equal 0, we get the y-intercept, right? So b gives us that y-coordinate of the y-intercept. Would be 0, comma, b. Okay, and then of course we are going to need this no matter what form you're trying to put it in. If you're given information to plug in to get a linear equation, you're going to need the form or the format of the point slope form of the equation, okay? This one is formula and form, right? Point slope. Okay, and it looks like this, okay, of course, and I'm going to put it this way. If we're given the point x1, y1, okay, and slope, I'm coming to the question, let me finish this quickly, of m, the equation of the line is given to us by this formula. Y minus y1 is equal to slope x minus x1, okay? Let me see what that question is there, okay? Alrighty. Okay, when the question is asked us to find equation of the line, should we have the answer? Okay, that's a good question, Michelle. Michelle's asking me when we're asked to give the equation of a line, what form should we end up in? What form is it going to be? What do they want the answer in? Most times, I'm noticing a lot of textbooks prefer slope-intercept form for your final equation, your final answer. Some of them like standard form. It just depends. Most of the time, it'll tell you somehow in the problem. So I guess really you got to take the context of the question. That's really kind of what I can say. For now, though, what you can do is just try practicing putting it in both forms, really, and that'll be good. I mean, I'm grading these, so I mean, once you start with automated, once we start with automated grading, you'll have either standard form or slope-intercept as correct answers. So if I were you, I'd practice putting it into both forms anyway. I think if you're dealing with a lot of problems in a short amount of time, slope-intercept, solving it for y, the last thing you have there in parentheses, would probably be the best thing. But it depends. If it asks for standard form, though, you do want that first format that I had at the top. Okay? So let's kind of take that question by question, okay? And we'll see. All right, so first off, let's kind of talk about, let's practice with just finding an equation given some certain information. Okay, and let me go to your homework here too, because I want to give you guys problems, you know, similar to what you're going to face there. Okay, I'm going to look at number 2 in the homework, and I'm going to do something similar to that, okay? So this would help you with something in that area. And the reason I'm choosing number 2, if you look at number 3 in the homework, it gives you a point and a slope. Well, in number 2, you have to find the slope given the 2 points. So really, we're kind of looking at something that'll help us with all of them, really, anything that has to do with where you would have to plug in a slope and a point. So, okay, so I'm going to give you guys 2 points, and we're going to find the equation, okay? So here's this one. Let me kind of make the room here. Okay, there we go. All right, let's see. It doesn't want to shrink for me. Okay, I'm trying to, it usually will shrink the ribbon up top for me. So here's an example. So given, and we're going to graph this afterwards too. We'll graph every time just to practice. Given the points, -3, 5, and, okay, and, excuse me, and let's see, let's have 4, 1, give the equation of the line. And look, this is my shorthand for equation. EQN is my shorthand for equation. I'm going to put this once at the top. And just when you see EQN like that, that's me writing equation. Okay? That's my shorthand for it. Give the equation of the line formed by these two, okay? Let's say they both pass through. Okay, so while I'm writing this, you guys could be starting on something. You guys could be starting on the slope formula, right? Label one of them x1, y1. Label one x2, y2. So I'll do that. Let's see. Let's make a little bit of room right here. We're going to say, okay, that first point up there is going to be x1, y1. See, I'm writing a little red note above that point. Oh, I wrote a 2. I got to stop doing that, huh? 1. Okay. The subscripts have to match. For whatever point, this point will have the same subscripts. Okay, so one point will have the 1s, another point will have the 2s. Okay, so let's first find the slope. Okay, so here's our solution. First, the slope. M is our universal variable for slope, right? And that formula goes like this. It's y2 minus y1 over x2 minus x1, right? This is your formula for slope. And you guys, since there are a lot of formulas coming up, like with this section, and you're going to run into more formulas as we go along, I would start collecting those index cards. I think I mentioned that a while back when we looked at the exponent rules the first time. But for each chapter or whatever, you might want to go ahead and get yourself a big 5x7 index card to collect the formulas on, you know, just to have it with you. Okay, so let's plug these values in, okay? So we will have in our numerator, okay, we'll do the 1 minus 5, y2 is 1, okay, and then 5 is y1. And look, it doesn't matter which one you allow to be y1, x1, y1, x2, y2. You could swap them out. But whatever you do, you go in, you keep it like it is as you start plugging numbers, and you can't be swapping it. So anyway, the new denominator will be x2 minus x1, so we'll have 4 minus a -3. 4 minus, and in parentheses I'm going to put that -3. Be careful with your signs, okay? It's important to be very safe with your signs. So we'll have 4 and what? Plus 3 is 7, okay? Minus a negative becomes plus, right? 4 plus 3. So we have -4/7, okay? So now what I'm going to do is take this slope, and I'm going to use one of my points, and I'm going to use this point slope formula that I have just above the problem here, okay? I'm just going to kind of leave that up there, okay, for us, leave just the formula, okay? So we want to take that formula, I'm going to write the formula in red just so you can pick out what the formula is we're using in the problem, okay? So the formula, I'm going to write it out every time I use it. Y minus y1 is equal to slope x minus x1. Okay, and so let me kind of label that too. This is point slope form. Form and formula, whatever you want to call it. In this case, in context, it's formula. But it also is a legitimate form of the equation of the line. Okay, so this is first. Let's say first we found the slope. For people, I think some people just kind of came in. So first we find the slope. If you're not given the slope, second, you're going to go to the point slope formula. Okay, so let's plug it in. So let me grab another color pen, and I'm going to do that over here to the right. So we're going to have y minus, and I'm going to keep my x1, y1 point that I was using before. So x minus 5, which is y1, is equal to our slope of negative 4/7, right? Okay, open parentheses, x minus, and x1 is negative 3 again, so negative 3 in parentheses. Be careful. And you could just make a larger parenthesis there too. That's fine. Let me kind of make a bigger one up front too, just to kind of do that, just to show it who it belongs to. So it goes with this guy. Okay? Now let's simplify this thing, and what we'll do, Michelle, is we'll put it into the slope-intercept form of the equation. Okay, first. Especially if there's a fraction, if my slope's a fraction, 9 out of 10, I will tell you to put it into slope-intercept form. Okay, so we'll have y minus 5. We're going to leave that 5 on the left for now. Okay, we're going to distribute that negative 4/7. And here's what it'll look like. So we'll have negative 4/7 x. Now, look up there, okay? I want to just kind of take this on the side and say that, okay, this is now going to be what? X plus 3. Be careful with that. I should have written 2 steps, but that's okay. All right, so we will have negative 4/7 x, right? Then plus 3 times negative 4/7. So let me go ahead and write that out. I guess that would probably be the most prudent thing to do here. So we're going to have minus 4/7, right, times, I'm going to make it bigger, 3/1, okay, just to kind of give you the multiplication of the fraction. The reason I'm writing it like that is because you want to see if something will cancel, just to make life a little easier right there. When you have fractions going into that part, you have to be super careful. Sometimes take it out on the side, simplify it, bring it back. That's something that keeps things a little under control as far as organizing your work. Okay, so we're going to have what, 12/7 minus 12/7. Okay, so now we're going to go ahead and add 5 to both sides. We want y by itself, right? Okay, so let's go ahead and add 5. And you are going to need to have a common denominator. So let me clean it up here, and I'm going to kind of do this. Watch. Y is equal to negative 4/7 x minus, and I'm going to put the 12/7, okay, plus 5/1. Now you do need a common denominator, right? And this is if you're not going to multiply out. We're not putting it into standard form, so we can't really multiply out the fractions, right? We can't use common denominator like we did when we had only one variable. We actually will have to deal with the common denominator in the fractions this time. So 7 times 1 is going to be 7, right? So we're going to have 7, and then the numerator 5 times 7. That'll give us our common denominator. And look, what I'll do is I'll take it out on the side. Let's do this. Okay. Okay, so let me circle that. Come with us. I'm going to take this out over here. So negative 12/7 plus 35/7. So we have what? Negative 12, or 35 minus 12, which is going to be 23. Correct me if I'm wrong, but I think that's 23. Yeah. Okay. Like I'm not trusting myself with subtraction lately for some reason. So yeah, that's right. That is correct. Okay, now we can come back into the equation and put that back. Okay. And so in slope-intercept form, which for now, for this example, Michelle, I'm going to leave it like that. Okay, so we'll actually have a positive 23/7. Now, if you're asked to plot, if you're asked to graph this, you might want to do mixed numbers or decimals, just so you can get between the correct integers. That will help you out a lot. Leaving it in improper fraction form like this is great if you're not being asked to graph it. if you are being asked to graph it, you at least would like to have the y-intercept, you know, correct. So this would be where? This would be 3 2/7. So it would be between the intercept, 23/7 would be, let's see, between 3 and 4. Okay, and you could do that, but I wouldn't ask you to graph something at the level you're at right now, guys. I really wouldn't put this one for a graph problem, making you graph it after the fact. This would be one where you could find the equation, yes, you know, but this wouldn't be the graphing one. So I'm going to take us into some other examples for that I have over here on the side. And okay, let me get those examples out. Are there any questions right now? Let me get my questions box open. And anything right now? Okay, anybody? Let me know if you have a question about anything. Okay. Now, here we are. Okay. Okay. Okay, here we are. And I gotta have a sip of my drink. I have a sore throat today. I'm so sorry. Thank y'all. Excuse me. All right, so next I want to talk about some special things. It's topics that we didn't really get to talk about very much last time. So I'm going to put up a new page here, a fresh one. Okay, so we're going to talk about things like parallel, perpendicular, vertical, horizontal. Let's go back to the concept of a slope, okay? Just kind of think of slope, we said, is basically the slant, right, or the pitch of the line, slant / pitch, okay, of a line, okay? And we said, I'm going to write a little equal sign here. We said it's, I'm going to put my M up front, okay? All right, so when we have a positive, okay, let me say one more thing. Rise over run, that's what I wanted to say. Don't forget rise over run. I'm going to use the concept of rise over run, you know, in my lecture, in what I'm talking about right now. So kind of recall that too. Okay, when the slope is positive value, okay, if it's a positive value, it's going to, I'm reading it, it's like reading from left to right. You're going to have from left to right, it's going to be going uphill, right? It could be shallower, but at any rate, no matter how shallow or how very steep it is, I want to make that a little steeper. Okay, very steep, or it could be very shallow. Okay, it's positive. It's going to go uphill from left to right. Of course, left to right. Okay, and then if slope is negative, it's going to go the opposite way, right? It's going to go downhill, whether it's shallow or steep. It could go very steep, right? It could go super shallow. At any rate, from left to right, it's going to be going downhill. From left to right. Okay. Okay, now there are two other versions of this that we can have, okay? What about up and down, straight up and down, which is vertical? Okay. Now look, go up to positive, okay? Let's say this first line I drew on this positive one up here, okay? I'm going to start drawing that in red just to call your attention to it. Look at the positive, the first line I drew for positive, right? Rise over run, we would rise in a positive direction, right? And then we ran in a positive direction, correct? Think about this. Okay, for negative, rise over run, right? First we would not rise, but we would fall in a negative direction, right? And then we would run in a positive direction, right? When negative over a positive is negative, correct? Okay. Or you could rise positive and run negative, right, as we saw last time. Let's take a vertical line, okay, and think about the 2 points on here, okay? Okay, and let me write the words for that. You think about that. Think about rise over run and what would the fraction look like there, okay? So slope is something. I'm going to leave that blank, and I'm going to put vertical line. Okay, and then the next one we're going to look at is going to be a horizontal line. I'm going to make that horizontal line. I'll put 2 points on it afterwards, and we'll look at it the same way, and we'll suss out what the slope would end up being. Horizontal line. Okay. Get my red pen here. The vertical line, rising, doesn't really matter. You can rise. In this case, these 2 points are 3 apart, right? So look, my slope ends up being 3 and run 0, right? Over 0. So what is it called when you have 0 in the denominator? Can anybody tell me, what do we say when there's a 0 in the denominator? There's actually no value, right? In other words, it's undefined, right? We say there's an undefined slope, okay? So we'll call this undefined vertical line. The slope has no value. We can't put a value in. A 0 appears in the denominator. Okay, and I'm going to put a little parenthesis here. A 0 ends up in the denominator. Okay? Okay, so undefined. There's no value. You can't put a number on that slope. Okay? Now, as opposed to that, let's take a look at the horizontal. Okay, and let's put a couple of points there. Okay, rise, in this case, the slope ends up being this. What? Rise 0, right? Up and down 0. Left to right, in this case, 2, whatever. It doesn't matter what it is. It could be 1,000. 0 divided by a non-zero number is 0. So when your slope, when you calculate a slope and it becomes 0, okay, it comes out to a legitimate 0, you're going to have a horizontal line, okay? And in case you forget, you know, a vertical line, the slope, when you're calculating it, you're going to have like some number. I'll just put 1 just to have it. 1 over 0. Your rise 1, rise however many, and run 0. So you can see that you're going to rise, run, rise, no run, rise, no run. You're going to end up with a vertical line. Okay? And then, of course, with the horizontal line, you're going to end up with 0 over something, right? Or just put a 1 for now. Okay. So if I'm rise 0, run 1, right? Let me see. Do it right under. Here's a point to start at. Rise 0, run 1. Rise 0, run 1. You're going to start shaping up a horizontal line, okay? Just like we saw in, you know, in the example there. Okay, it's not scratching out. Okay, I see a question. Let me go grab the question. So that's your horizontal versus vertical lines. Yes, that's my next thing I was going to say, Viv. That's where I was going with that. Thank you very much. Yes. Okay, so when you have these special slopes that I have written in red, okay, the equations don't quite look like if you had a positive or a negative slope, okay? The equations are special, okay? And I'm going to write that underneath where I have the word vertical line, okay? For a vertical line, the equation of that line, this is going to be something you need to try to remember because it will fool you on a test. It fools you because it looks like somebody solved, it looks like a solution, right, that we just finished dealing with. For this one, what do you think the equation is going to be for an undefined line? Okay, these guys are going to look like this. X is equal to some number A, where A is just any real number, okay? Okay, and I'm going to put that real number. Okay, so think about, I'm going to go underneath here, I'm going to do a couple examples where we're going to actually graph a vertical and a horizontal. For a horizontal line, the equation of a horizontal line is just the other coordinate, right? It's going to be y equal to. Okay, so we'll have y is equal to b. B is just some real number, right? Okay. So when you, how do you tell when it is a line they're talking about or when it's a solution talking about? That's a question I get quite often. It might have been on the tip of your brain. Maybe I beat you to the punch. But how you tell is by reading your problem and taking it in context, okay? So I might say this, okay, for example. Well, actually, I don't have to guess. Let me bring up the homework. I want to see how it's being asked there. Okay, come on. Okay. Okay. Okay, so let me quickly do this. I'm just going to, I don't really see one like what I would want to ask. It's probably going to show up and sneak up on you, actually. Okay, so if I'm asking you to graph, for example, when I mean in context, graph the linear equation or graph the line of this equation, okay? Let's say x is equal to 3. Okay, no problem. You're welcome. Okay, so see, in context, I'm calling it an equation, okay? So be careful with that. You may see a problem on a quiz or something online that says, which of these are linear equations? And you might have a bunch in slope-intercept form like we've dealt with before, and you might see y equal to 3 or x equal to 1 popped in there, you know, just kind of snuck in there somewhere. Well, those are lines. Now we know those are actually horizontal or vertical lines. So be careful with those, okay? Okay, textbook page 173, examples 1 or 2. So there are, exactly. So this is how you're going to do those, Michelle. On page 173, examples 1 and 2 will help you guys have more practice, okay? So let me put that for y'all, okay, to practice that. Page 173, and I'm just going to put that for you guys so you have that. So you can practice these a little more. So let's graph the equation x equal to 3. Now these are so simple. And we did the XY chart the other day, and I'm going to show you guys, like, if you totally forget what direction the x equation goes in, you know, if you say, okay, I know that's going to be horizontal or vertical, but I forgot, you know, which one is which. Here's how you can tell, okay? Let's have an XY chart. Here's how this works. It doesn't matter what y is. X is always going to be 3. Okay, so pick you a couple of, or put 3 a couple of times or 3 times down there, and just do this: -1, 0, and 1, or 0, 1, 2, whatever you want to do. Doesn't matter what y is. 3, x is always 3, right? Because that's the equation of the line. And plot those points, and that will surely remind you. +3, -1 is here. That'll surely remind you that it is a what? A vertical, right? +3, 1, 2, 3, up and down 0. That one's right on the x-axis, right? And then 1, 2, 3, up 1. You can see that you have this vertical line shaping up, right? You must fill in your line. Don't forget to fill in the lines when you're graphing. So this is the graph of the line x is equal to 3. Okay. Okay, let's see this. If you want me to label my points, this is 3, 1. I'm going to label just the 2 here. 3, -1. Okay, and there's 3 zeros on the axis there. Okay. Now, okay, let's go ahead and, if you forget, let's kind of just go ahead and do one with the y. Okay, so let's make that one was part A. We'll make this part B. Okay, and so let's kind of ditto. I'm going to shorthand a lot of this. So now we're going to graph the equation y is equal to -4. Okay. So practice this. Practice doing a little XY chart for that, you guys. Try it out. Uh-oh, get my color there. All right. Try it out real quick while I'm doing this. And then y is -4. It's not going to be vertical. We know it's going to be horizontal, right? Okay. So I'll give myself a little more room down there. Okay. Excuse me, y'all. So now, go ahead and make yourselves an XY chart, okay? And now instead of y always equal x equaling something, y is always going to equal whatever the equation indicates. So write that number down 3 times, because you know we're going to want 3 points. Yes, we know 2 make a line, right? But 3 will help you see that you're getting it right, right? It'll give you that direction, the definite. You'll be confident about your plotting. And so look, let's go ahead and just put 0, 1, and 2. And look, I'm telling you guys, when you have to pick points, when you have to choose the x and plug in and get the y and other equations, choose nice numbers. You don't have to choose 100 or 1,000. You don't have that much graphing space anyway, right? Try to keep stuff that's easy, like 0 usually will cancel a term out or something, you know, that kind of thing. Just kind of, the more you do this, you will get better at choosing your x's, by the way. You'll get better at it. You just have to practice. It is all in practice and start with number 1. Best advice I give students, open your notebook, read the question carefully, and start with number 1. And if you don't know what it's asking you to do, ask your teacher. Call me. Get in touch with me. I'm here to help. Let's plot 0, negative 4. 0 left to right, down 4. It's going to be here. Okay. And so what? Let's go 0, negative 4. Okay. And then 1, negative 4 is here. 1 to the right, down 4. 2, negative 4. 2 to the right, down 4. Okay. So we have this nice little neat horizontal line, which is the graph of the equation y equal to negative 4. Okay, doke. Does that help? Okay, so the next little special situation we want to take a look at would be when we deal with comparing 2 lines that are side by side. And that would be our horizontal, oh, not horizontal, listen to me, parallel and perpendicular. Okay, so let's take a look at those, okay? And I'm kind of going down from here, and I'm going to, yeah, give us lots of space. So next topic. Okay, let's talk about parallel lines. Okay, and by the way, oh, that should be an A, sorry. Parallel lines, by the way, I can shorthand this in this manner. I can write 2 parallel lines. You guys may remember from geometry in high school or whatever that was, right, long ago for some of us. Parallel is just 2 miniature parallel lines. It looks like a number 11. Parallel lines, right? That's what you're going to see sometimes, okay, if shorthand's happening. Okay, and then perpendicular lines would be the other one. The shorthand for perpendicular, which you will see sometimes in textbooks or if you're looking it up for extra help online or something. You'll see a little perpendicular wall, right? You see the floor and the wall here. It's like an upside down capital T. Perpendicular lines, okay? Okay? So there's the shorthands, right? Okay, so what about them, Karen? What about them? You went off on the representing the words, but what about the math? Here it is. Parallel lines have the same slope. Okay? So if I give you a line, if I give you one line, now let's call it line number 1, and I say I want you to give me the equation of line 2. You know what line, if it's parallel to line 1, but line 2 passes through a certain point. As long as we have a slope and a point, we can give you the equation of any line, right? Well, that's what they're doing in the homework, okay? And the way they're wording it, okay? Look, what I'll do, let me show you this in a graph. This is what this will look like, okay? Let me open my my tablet keeps closing on me, so let's see, I'm gonna illustrate this for you right over here, okay? I'm gonna do 2 pairs of axes, one for the parallel lines, one for the perpendiculars here. Okay. All right. Let's go here. Okay, they have the same slope. Okay, so let me go ahead and draw in. I'm going to get this. Let's see. I'm going to go 3, 4, 3, 4. I'm just trying to draw some nice, pretty parallel lines here. Okay, so these are going to have. They're going to be perpendicular. Okay, so here's line 1. And here is line 2. Okay, so we'll label them that. Okay, and so this will be L1 and this will be line 2. Okay, notice for one thing this slant is the same, right? Okay, so each of these has a point. Okay, so this line 1 has slope of 1, right? So we can say slope 1 is equal to slope 2, right? Or we can also say that line 1 is parallel to line 2. Okay, just trying to help you to drive the point home there. For the perpendicular lines, though, okay, they are going to have, and wake up and listen, okay, their slopes. See how I'm going to put this here. Here's my pen. Come on, pen. They can't wait. I'm just trying to help y'all with suspense. I know y'all are just, y'all like that. No, kidding. The slopes are going to be opposite reciprocals. Okay? Opposite signs, right? Opposite signed. Oh, I meant to put signed. Okay. And reciprocal of one another, okay? Okay, so in other words, come on back, pen. Okay. Slope 1 would be, or slope 2, you could put one side's going to have slope 1, the other one's going to have slope 2. Slope 2 will be, let's see how I'm going to do this. Let's do the opposite of slope 2's reciprocal, right? Remember that -1 exponent tells me reciprocate. Okay, another way to write it would be the opposite of 1 over this other slope. Okay, here's examples. Okay, if line 1, okay, example for parallel lines here. Okay, I'm up under parallel lines. If line 1 has the slope equal to 2/3, then the line you're being asked to plot or graph has also 2/3 as its slope. Okay, so I'm just saying, for example, I'm going to do a real good example where you give the whole equation in a minute. For perpendicular lines, and here's an example here, if line 1 has a slope, and I didn't draw those in yet, let's say line 1 has, let's see, okay, has a slope of, let's see, 3/2, okay, and well, let me just use 3/4 just to make it different, okay. Let's say 3/4, okay. If line 1 has 3/4, then line 2 will have what? It will have, if this is first one's positive, it will have a negative, and then you flip that fraction, right? 4/3, okay. So what happens is when you would go to graph line 2, and look, let me go ahead and say this is line 1, okay, because it's a positive slope. And then line 2 would be perpendicular to that, okay. I'm just trying to draw a perpendicular, arbitrary perpendicular line. So line 2, and when they intersect, they create a right angle. That's perpendicular lines, right? So notice the signs are definitely different. Look at the pitch of the line now. When they're perpendicular, one's positive, one's negative. And if you would follow the rise over run, you would find that they flip, right? They rise rise and run with the other number, okay? So they reciprocate. Let's do an example similar to what you would have to deal with in your work. Okay. So let me get this good example here. Good, right here. Okay. Excuse me. I need some more typing room here. Let me make some room. Do we have any questions, you guys, so far? Okay, and I'm going to mix them up. Hopefully you guys took some notes. I can go back up and go retrieve that for y'all if you need me to scroll back up. That's fine. I'm going to go ahead and write out the a couple of examples for y'all here, okay? Let's see, example. And let's make this A. Okay, and let's see. Just overall, I'm going to say this. Let me go ahead and type and make it bigger too. Okay. Make that go. Uh-oh. Sorry, guys. Back up. Okay. All right. So find the equations. The equation with the given information. Okay, and that's going to be for each thing. Okay, we're looking for a linear equation given this, okay, given certain information. Okay, so in A, I'm going to say we want to find the equation of a line, okay, that maybe passes through point or containing a point. Let's say it contains or passes through is the same thing. Containing the point 1, -1. Okay, and let's see. Has a slope of -2/3. Now this is not telling me perpendicular or parallel. This is one that's old. Okay, I'm just trying to draw you back into thinking like this. Given certain information, what can we do? While I write out the next two, I'm going to go below and write the next two. I want you guys to try this one, okay? This is one we've done already, okay? So what do? I'll start you off. We let this be x1, y1. You need your point slope formula, and you have a slope of -2/3, right? M is -2/3. So we're kind of good to go as far as plugging it in to the point slope formula, which looks like this. Y minus y1 is equal to slope x minus x1. So it shouldn't take you too long, actually. Try them while I write these other problems, okay? And we'll write these two side by side. So let's see. Okay. Next thing is going to be, we're going to find the equation. Okay, this one we're looking for is perpendicular to the line. 2x plus y is equal to 2. All right. Semicolon containing the point -3, 0. And I'm going to scroll down a little bit and do the next one. Okay. This will be part C. Okay. Oh. All right, so parallel. Okay, that's not what I wanted to write there. Parallel to the line y is equal to -3x, containing -1, 2. Okay, all right, so if you've done the part A correctly, here's what it'll look like, okay? So we would plug in y minus -1, right? Minus a -1. Be careful with the signs. Our slope is -2/3. And then we have x minus 1, right? So what we would do here is we would simplify both sides. You don't want to move stuff over just yet, right? Y plus 1 here, -2/3 x. Distribute carefully with these fractions, right? This is going to be what? -2/3 times -1. Be careful. If you got to write that in a couple steps, be very careful with that. That's where a lot of people tend to mess up. So don't do that. Don't mess up. Okay, so we get what? +2/3. Now we're kind of not done, right? We still have to get the y by itself if we want slope-intercept form. So we'll subtract this 1 off of both sides, right? Now, here's what I'm going to do for you. I'm going to take this guy, this little addition of the fractions, I'm going to take that off to the side, okay? Okay, so here's what it's going to look like. We're going to have 2/3, which is positive, minus 1, but 1 we can write it as 3/3, right? Which is still 1. So we'll get what? -1/3, right? 2 minus 3 is -1. Okay, so the term there, that last term is going to end up being negative of subtraction, right? So let me come here and write it. Okay, the final answer, the new equation is y is equal to -2/3 x minus 1/3. Okay, and so what I've done here is I'll put it in slope-intercept form. Okay. All right, so let's go to the next one, part B. All right. So now we want to find the equation of a line perpendicular to this line, right? Perpendicular to this line. When I gave you guys standard form, right? And let's call this line 1, okay? Okay. All right. So the slope of line 1 for this formula, I said the slope would be the opposite of A over B, right? So what is A here? This is A is the coefficient, the 2, and B would be the number in the coefficient on Y, which is 1. Or what? The opposite of 2 over 1, which is what? -2. So that's what I want to find, a line that's perpendicular. The slope of the new line will be perpendicular to this, which is telling me that my new slope, right? My new line will have slope what? I'll call it M2, right? If it's perpendicular, it's going to have the opposite sign, so it's going to be positive, and the reciprocal of 2 is 1/2. So positive 1/2 is my new slope because of perpendicular lines, right? Okay, so let's go on in. We have a point, right? -3 is x1 and y is 0. This is actually kind of nice when you go to plug it in. Let's write our formula out. Y minus y1 is equal to, let me turn it down, x, let's see, slope, x minus x1. Okay, so let's go forward here and we will go ahead and plug and chug. Okay, so y minus y1 is 0. That's kind of nice. So the new slope, positive 1/2, and then x, what? Minus a -3. Be careful with the signs. Okay, so now we're going to go up over here on the right, make another little column, and we will simplify. On the left, y minus 0 is just y, okay? See, this is kind of nice because you'll have your slope-intercept done. Okay, so if we distribute that 1/2, by the way, this is what? X plus 3. Okay, so be very careful with that. So now we'll have 1/2 x plus 3/2, right? Okay, and I have to kind of make it snappy, you guys. Let's kind of let's go through part C, and we will kind of I guess we'll practice graphing another time because we're running out of time. I'll take some of these further maybe in a video later if I have time. So parallel line, okay, we know the beauty of it, okay, is the coefficient on x is my slope, right? So the slope of line 1 is -3. What happens with parallel lines is the slopes are the same. So my new line slope will be the same thing, right? Okay, and so I also have my x1, y1 here. So let's plug in. Let's get our formula up. Y minus y1 equals slope, x minus x1. Gotta love it. Okay, so now what? Y minus 2 is equal to -3. That's my slope. X minus a -1 is what? +1. See, you're at the point where you can just start doing that. With minus a negative in your head, you can say that is +1. Be very careful, though. Make sure you are ready for that. If you're not, be honest with yourself. So this one works out to be what? Y minus 2 is equal to distribute -3x minus 3. Be careful. Look. Distribute -3 times x, -3 times +1. I'm finding too many of you guys are not distributing correctly to the second value, okay? So now we want to add 2 to both sides just to get the y by itself in the slope-intercept form. Y is equal to -3x minus 1. We can easily put this one into standard form by adding 3x to both sides. This is slope-intercept, right? So you could say, I mean, this is legitimately done. We could say that +3x plus y equal to -1 would be standard form. This is also correct. These two versions of this line would have the same exact graph, by the way, because they're equivalent forms. And they share the same what? The same solution set. Don't forget, a point on a line is one of the infinitely many solutions that that line has. Any point on a line should create a truth statement when you plug it in. We looked at that last time. If you need more of that, go ahead and look at the beginning of the previous lecture, and you'll get some of that. But you guys, I'll kind of try to give you guys some more videos. I'm posting more on the YouTube channel too on this section. I actually already did the other day, so go on in and look at some of that if you need more help. I am here for you guys too, so be in touch, and you guys have a great day, okay? We will talk soon, okay? All right. See y'all soon, okay? I'm going to answer some questions. Oh, you're very welcome. Anytime, you guys. Okay.